Hi, it's Mr. Benson here again with the next activity that we need to look at, which is looking at equations which have pronumerals on both sides of the equation. Now, we really are doing the same sorts of things that we've been doing earlier, but we just need to follow the process carefully. So what do I mean by this? In the previous equations that we looked at, we only had the x on one side of the equation. In this equation here, you can see that I've got x on this side and I've also got x on this side. Now, when I'm trying to solve an equation, what I'm trying to do is find the value for x. Now, I can't find the value for x if my x is split across two sides of the equation, so I need to get all those together. Now, in order to do this, basically what I'm doing is combining like terms. Now, like terms are something that we've discussed in algebra previously, so it's a skill that you should already be familiar with. Now, I'm going to work through this example and then I'll show you a couple of others just to show what we can do. Now, one really important thing to remember when you're doing this is that there's not just one right approach. I want to get all my x's together, but I could get them all on this side of the equation, on the left side, or equally I could get them all on the right side. It doesn't actually matter. Now, what I often do is I tend to leave the bigger number of x's where they are, or the most positive number of x's where they are, because then I'm more likely to get a positive answer at the end, which just makes my life slightly easier. Well, I think it does anyway. But in all other respects, it doesn't matter what you do as long as you follow the ideas from the previous videos, mainly that the equation must be balanced because we always do the same thing to both sides. So I'm going to go with the idea that I want to get rid of the x from this side of the equation. Now, although there's no sign in front of it, if I've got x by itself, I know that that's a plus x. Now, effectively, this is adding x to the left-hand side of the equation. So we go back to the process that we've looked at in the last videos. The opposite of adding x is to subtract x. So I'm going to subtract x from there, and I'm going to subtract x from this side of the equation. Now, x minus x, we all know, is 0. We're cancelling something, which is what we do at every step. Over this side, 2x minus x, I can evaluate that. So what I'm left with is 3 equals 2x minus x, well, it's now just x minus 1. Now, things have become simpler, and obviously I want to get rid of the minus 1. Now, I'm subtracting 1, so the opposite is to add 1. So I'll add 1 to each side of the equation. Doesn't really matter how you write that. So on this side, minus 1 plus 1 will cancel. So all I'm left with now is x equals 3 plus 1, which is 4, and I can just write this around the other way. X equals 4, and I've got my answer. Now, moving on, combining like terms, just a quick refresher of that. We need to be able to identify the like terms in any equation that we're working on. Now, this is, as I said, something that we did in algebra, so it's something that should be, pretty familiar. So when we're thinking about like terms, if something contains an x to the power of 1, so not x squared or x cubed or anything weird like that, so a term like this one here, it is like with any other term that has x's to the power of 1, like that. Now, it's not like with x squared, and it's not like with just numbers by themselves. Now, numbers by themselves are all like with each other. So if I just want to change my color here just to make it a bit clearer, I've got numbers here and I've got numbers here. Now, one thing that's worth remembering as well is that the sign actually belongs to the number or the term after it. So really, this plus 3 is the term. So they're like terms, the minus 1 and the plus 3, the 3x and the 2x are like terms. The 4x squared is currently sad by itself because it doesn't have any like terms at this stage. Now, when we look at the rest of this equation, the xy, now that's a bit of a special one because at the moment we don't know the value of y, so y is another variable, but it's not the same as x. and it's not a number that we know anything about. So this is not like with anything in this equation, and this is not like with anything in this equation. Now, the good news, because we're doing linear equations, we're only dealing with equations with x to the power of 1, like this. Now, what that means is that we don't actually have to worry about strange things like this in this sort of equation. Now, if you zoom through this stuff and get onto more advanced equations later on, then you definitely will need to worry about the like terms that you choose. But at the moment, this linear equations makes it simpler for us because we only have numbers or x to the power of 1.